Alright, this should be your second video. Now we're going to determine, we're still on number 1. Now we're going to determine whether or not this function is either odd degree or an even degree function. And the easiest way to tell this is just counting the strokes of this graph, and I'll tell you what I mean. So you see how I can make 4 different strokes here, so let's look. 1, 2, 3, 4. So I counted 1, that's my second one, that's my third one, or that's my fourth one. So that's, do you see how that's my fourth? That took me about 4 strokes to draw this graph. So this one is actually degree 4 polynomial. So this would be my even degree function. Not too bad, is that right? Now if you look at number 3, I know it looks a little messy, but if you look at number 3, we can draw it with 1, 2, 3, 4, 5 different strokes. So this would be my degree 5 polynomial, or I can just say this is my odd degree polynomial. This wasn't too bad, is that right? Now let's go ahead and try to find our real zeros. Now if you remember the real zeros, that really meant all of my x-intercepts. So let's kind of rewrite that as my x-intercepts. So let's see how many intercepts that we have. We have 1, 2, 3, and 4 different x-intercepts, and those are my zeros. So we have 4 different real zeros. Now sometimes even if it's a even degree function or fourth degree function, it does not mean we're always going to have 4 zeros. For instance, I could draw my polynomial something like this, and it'll only have 2 different zeros, not 4. So I'm going to go ahead and delete that. But do you see how many that we have? So there we are. Now we have to determine the zeros of the function. Now before we do that, I'm going to ask you guys to recall how to write the functions of a graph. If you guys remember, we wrote it somewhat like this. I recall that this was f of x. So on my parentheses, we had to write x, I believe that's 6, x minus 6, x minus 3, and those were my x-intercepts, like -3, -6, and that was my +5, so we go x positive 5, and then this will say x positive 9. Now that's my function. That's on your bonus parts on the very bottom. That's where you should write this right here. But when you're looking at zeros of the function, zeros means you have to set each of these equal to 0. So when you have x minus 6 equal to 0, that's only going to give you x is equal to 6. So basically what I'm trying to say is that it's the opposite of whatever that's in here. So since we have -6, -3, +5, and +9, we'll now have x is equal to that little bracket thing, and it'll have +6, +3, -5, and -9. And close the bracket. Not too bad. And I want you to look at number 3 again. I know number 3 is a little messy as of right now, but someone should pause this video right now and let other people try number 3. And then we're going to go into and I'll just explain number 3 when you guys replay the video. So right here we have 1, 2, 3, 4, 5 different zeros. And I'll say that my zeros are x is equal to 4, +4, +2, -2, -3, and -5. I hope this video helped, and we're going to go straight into domain and range on the next video, I believe. And we're going to finish it out with min, max, and local min, local max.